Hello, my name is Mashahid Rasul. This is Homework 8. For Homework 8, we are given three problems. This is the first problem, 14.3. Here we are to modify a traffic light control finite state machine given in table 14.4 so that it makes the lights go red in both directions for one cycle before turning a light back to green. And we are supposed to show a state table and a state diagram of the finite state machine. Here I have the state diagram that I have made. It starts out with north-south lights being green, east and west being red. And if there's a car waiting in the east-west direction, then it's going to go to the cycle of yellow and then red. This is one of the red states for both lights. East-west is red and north-south is red. And then it goes to green east-west. East-west becomes green. And as long as there's a car in east-west, it's going to stay in that state. If there's not a car there, then it's going to continue on and east-west becomes yellow and then red. This is the second state where both of the lights are red for both directions. And then after that, it just goes back to north-south being green. Here is the state table, and this is the basically the same thing but in state format and next state. I'm now going to show you the code. Here is the code for the part 1 problem 14.3. Here I have a clock signal, a reset, and a east-west sensor. And I have here north-south green, yellow, red lights, east-west green, yellow, red lights. They're both 3 bits. Here I have a reset. Whenever reset is pressed, is going to go back to state 0. And otherwise, if there is a rising clock edge, when in state 0, north-south is green, east-west is red, and there's going to be an output that's going to tell us which state we're in. And if there's a car waiting in east-west direction, continue to the next state, otherwise stay here. And then state 1 is north-south is yellow, east-west is red, then continue. North-south is red, east-west is red, and then go to the next state. And then state 3 is north-south is red, east-west is green, and the output is going to be state 3, and as long as there's a car waiting here, it's going to stay here, otherwise it's going to go to the next state. And the next state is north-south is red, east-west is yellow, and the state is state 4. And then it's going to go to the state 5. This is the last state. North-south is red and east-west is red, and after this it goes back to state 0 where north-south becomes green again and east-west is red. Here's my test bench code. Test bench code, I have signals for the sensor, the output, clock reset, and the 2 lights. Here I ported them respectively, and I am testing out. It starts out with reset being 1 and should do nothing here. And when reset is 0, the sensor is 0. Here there is no car waiting in the east-west lane, so for about 1,000 nanoseconds it's going to stay in that same state 0. And then after 1,000 nanoseconds there is a car waiting, so it's going to cycle through the green, yellow, red lights. So I'll just show you this in simulation. I'm going to import reset, clock, output, the sensor, north-south lights, and east-west lights. I'll make these binary so we can see exactly which lights are on and which state we're in. So I'm just gonna run the simulation for about 3,000 nanoseconds. Running for 100 more. Okay, and make it full screen. And at this point, this is state 0 and clock is 1. So it is reading in the inputs. The input is green, yellow, red. So green light for north-south direction. And also from going from south to north, it's also green. And east-west is red. And because there is no car in east-west direction, the signal is 0. It's going to stay here as long as that signal is 0. And at this point, the signal becomes 1, indicating that east-west lane has a car waiting. Therefore, the north-south, green, yellow, red should start its cycle to yellow and then red. So at the next clock edge, it goes to yellow. And then at the next clock edge, goes to red. And this is one of those 14.3, what problem 14.3 asked for a red state in both directions. This is one of them. And at the next clock edge, east-west becomes green, and it's going to stay here as long as there's a car in the east-west direction. So it stays here as long as there's a car, and then here the car is not there anymore. And at the next rising edge, east-west is going to cycle through yellow and then red. And then after east-west has cycled through green, yellow, and red, this is one of the other state that were north-south and east-west are red. And then after this, it goes back to state 0. North and south becomes green again. And that is basically it for problem 14.3. Thank you very much. Hello and welcome to part 2 of homework 8. In this problem, we have to modify the traffic light control in table 14.4 so that it takes an additional input car NS, meaning a signal for the north-south direction that indicates when there is a car waiting in the north-south direction. Change the logic so that once the light has changed to east-west, it stays with east-west green until a car waiting in the north-south direction is detected. Only then it starts cycling through. So here is the state diagram that I have made off of that. It's my diagram starts off with north-south green, east-west red, and it stays here as long as there's a car in the north and south direction. And as soon as east-west is there's a car waiting in east-west direction and north-south is 0, meaning there is no more cars left in north-south direction. Only then it goes to the yellow light for north-south direction, and then it goes to the red light, and then it goes to east-west green, and it also stays here as long as east-west has cars going through, as long as east-west is 1. And then after east-west is 0 and there's a car waiting in north-south direction again, only then it goes to uh, east-west yellow and then east-west red. And then it goes back to north-south being green. Here is the state table. This is the same thing, just in states and next state. I'll show you the VHDL code for this part now. So here's the VHDL part. Here I have, just like in part 1, clock, a reset, but this time I have 2 signals, 2 sensors for east-west direction and north-south direction. Also I have just like in part 1, north-south lights and east-west lights. Here I have reset. When reset is pressed, goes back to state 0. And then when state 0 is gonna north-south is green, east-west is red, and it's gonna output state 0. And as long as there's a car in east-west direction, go to the next state. And if there's a car in north-south direction, stay in this state. Otherwise, you're always gonna just stay in this state as long as there's cars here. If there's a car in east-west direction, then go to the next state. And when you're in the next state, go to state 2. Well, which is this is the yellow state. So after yellow state, go to red state. And then when you're in red state, go to north-south being red and east-west being green. And then stay here as long as east-west has cars there. If not, then north-south has cars. Then you go to the next state. When you're in the next state, S4, this is where north-south is red and east and west is yellow, and then east-west becomes red. And basically this is the last state, and then it just goes back to state 0 and it starts all over again. Here's the test bench code. For test bench code, I did the same code as in part 1, same inputs, except for I added a sensor for north-south direction. So I'll just show you the simulation for this. I'm going to add in clock, reset, output, sensor east-west, sensor north-south, north-south lights, and east-west lights. And I'm going to run it for 3000 nanoseconds. And I'll make these binary so we can see what's going on. Okay. So at this point, we have north-south green, east-west red. North-south has a car here, so it's always going to stay here as long as that car is here. So it stays up until at this point. This point, east-west has a car here, but north-south does not. So it's going to, at the next clock edge, it's going to start cycling north-south green to yellow. So here we can see it's yellow now. And then at the next clock edge, it becomes red. And then at the next clock edge, um, east-west red becomes green. And it's going to stay here as long as east-west has a car here. So as long as east-west has a car here, it stays here. And as soon as north-south has a car again, it's going to cycle east-west green to yellow. And then east-west yellow to red. And now here both states are red. North-south still has cars here, so north-south is ready to change red to green. And this is basically the first state. So the whole cycle has been completed. And that's it for part 2, problem 14.6. Thank you very much. Hello and welcome to the last part of homework 8. For this problem, we are 14.9, we are given a table 14.4 and we are to modify the traffic light controller finite state machine so that it stays in the east-west green state as long as east-west cars are there. And here is the state diagram for this. Here I have everything starts off in north-south green, east-west red. So as long as east-west does not have a car there, it's going to stay in this state. As soon as east-west has a car, it goes to changes north-south green to yellow, and then it changes yellow to red. And here north-south is red and east-west is green, and it's going to stay green up until east-west has a car there. So as long as there's a car in east-west, it stays in state 2. And as soon as that car leaves, there's no more cars left. It's gonna change east, west, green to yellow, and then to red again. So here's the state table that shows the same thing. I'm gonna show you the VHDL code for this now. Okay, so here is the VHDL code. Here I have a clock, a reset, and a east-west sensor, and north-south lights, east-west lights, and a state indicator for an output, tells us which state we're in. And for this problem, I only had 4 states because it doesn't stay in, based off table 14.4, it doesn't stay in a red state for both directions. Here reset 1, whenever reset is pressed, go back to S0, the beginning state. Here in state 0, north-south is green, east-west is red, and it outputs state 0, or a 0 in binary. And as long as east-west does not have a car there, it's going to stay here. But if it does have a car, it's going to go to state 1. State 1 is the cycling process of north-south lights. So north-south was green here, it becomes yellow here, and east-west it stays red. And then it goes to state 2. When it goes to state 2, north-south becomes red, east-west becomes green, and when east-west is green, it's going to stay green up until east-west does not have a car left. And if the sensor detects that east-west is clear, there is no more cars, it's going to go back to state 3. And when it goes to state 3, east-west becomes yellow, and then goes back to state 0, where state 0 says east-west is red and north-south is green. So here's the test bench. In test bench, I have the almost the same code as in the first problem. I will just show you the simulation for this. For the simulation, I have here, I'm gonna run it for 3000 nanoseconds. First, I'm going to input the reset clock east-west sensor, the output that's going to show us which state we're in, the north-south lights and east-west lights. Then I'm going to run it for 3000 nanoseconds, and I'll make it full screen. Okay, I'll make these binary so we see which lights are going on and which state we're in. So it all starts from here. Here we have state 0. State 0 says east-west does not have a car here, so it's going to stay in this state as long as east-west does not have a car here. So north-south is green, and it's going to stay green, and then here we have a car present in the east-west lane. So north-south is ready for the next clock edge, and at the next clock edge it's going to change from green to yellow. So here we have yellow, and then next clock edge red. So here north-south becomes red and east-west becomes green. East-west becomes green here, and it's going to stay green as long as there's a car here. So it stays green, and then that car is gone. The lane is empty. So it's ready for the next clock edge. At the next clock edge, east-west is going to cycle through yellow, and then yellow, and then it goes to red. And this is just the S0 state again, state 0, where we started off from. North-south is green again, east-west is red, and there is no cars in the east-west lane, so it stays here. And that's about it for homework 8. Thank you very much.